Okay, so good afternoon. It's a good time to get started. I hope everybody got a great holiday weekend with happy shopping. Okay, but then we only had today and Wednesday left before we have the final exam next Monday, right? So time goes very fast. Let me go straight to our materials. Um, Last time we did something with the FQS model, right? So let me show you the class notes and then we start from there. Okay, so we started the FQS model last time, and our example is in module 10, slide 26. This online store sells calculators, right? So we have all of the information here, whereas we know the demand, we know the standard deviation, the lead time, the ordering cost, the unit cost, the inventory holding cost rate, right? How many weeks do we operate? And then the desired service level, on hand calculators 35, right? Schedule receipt 20. Schedule receipt means that today we are supposed to receive 20. Okay, we check it online and it says that the calculators will be delivered today. So we say that the schedule receipt is 20 and the back orders is 2, right? So last time what we did, calculate the economic order quantity. We just use the usual equation, right? And then we get the optimal quantity that we should order every time. So that's a good start. And then together with that, we calculate how much costly it is to operate at that point, right? Q star. And we calculate the number of orders per year and how many days that we wait before we make the next order, right? So in this case, on average, we're gonna order 4.39 times a year. That's our average number, so we keep that as our average. And which also means that we wait for about 83 days before we make the next order, right? 83 days, and then another 83 days, and then another 83 days on average. So last time, that's what we covered in class, but at the end, I also include all the remaining steps of this example, right? So today, our task is to go through the main steps of this example. And I hope that you really understand the intuition behind this system or behind this model. And then we can move on to the module 11. Module 11 is quite close to module 10. Of course, there's something different there, but the way to do it is quite similar. Okay, so let me go back to the example here, and we briefly review something, and then we move on to the new thing. Okay, so we are still at module 10 about the fixed quantity systems, or FQS. So the big topic that we talk about now is the FQS model, right? Earlier than this, we talk about the EOQ model.
Man, I'm gonna fuck.
But the EOQ is just the foundation for us to do the FQS. So now we're already done with the EOQ, and now we do the FQS model. And the example here is the online seller calculator. This is module 10, slide 26, right? So in part A, we find the EOQ or Q star. That's the optimal order quantity that we need to find, right? So remember the equation is we take 2R K, 2 times R times K divided by C times I. All of these are given by or in the question. And remember, the R here is the demand for the whole year. In the question, they give us the demand per week, but you need to multiply the demand per week with 52 weeks, right? In this case, we have 52 weeks. If I give you 51 weeks, then you only need to multiply with 51. Otherwise, it's going to be wrong, right? Because 51 weeks means that the store is only open for 51 weeks and takes 1 week off during the year. So you need to multiply with the correct number of weeks. Okay, so we already found the EOQ earlier, and the EOQ that we found is 100, and let me make sure. We found it to be, to make it clearer for you. In terms of calculation, we got it to be 147.20, right? But then we talk about the number of calculators. That's why we roughly route it up to be 148 calculators. Right, as a routed up. So in the homework or in the exam, if you do it right, please follow the instruction if we need to route it up or not, or do not route it at all. Sometimes we don't need to route it. Okay, so that's the very first part. We find the economic order quantity, right, or the EOQ, or the optimal quantity that we should order every time. Remember, under the fixed quantity model, we order the same amount every time, right? That's why we need to calculate that optimally. But what does that mean, optimally? Let me draw a picture to illustrate it. The quantity that we choose to order every time is 3 letters, Q, right? We can order it anyway. And on the vertical axis, we measure the cost in dollars. The first curve here is ordering cost, the OC, how much it costs to order in a year, and how much it costs to hold on to the inventory in the year, right? And as a manager, we are interested in the total of these two costs, and we call that as a total annual cost. So the minimum point on this curve, maybe I do not draw it totally correct, right? The minimum point, the lowest point of the cost curve is right here. And that's supposed to be our Q star, right? But the point that we calculated is 147.2. And we cannot buy that decimal number of calculators, right? That's why we need to route it, and we operate at that point, right? So we take that as our Q star 148, and our cost is right here. So this cost is a little bit higher than the lowest cost that it can be, right? But because we cannot operate at that decimal number of calculators, so we have to move it up a little bit to be here. So we incur the cost a little bit higher than the theoretical minimum point, right? So that's what we call the optimal quantity, because that will help us to minimize the cost as much as we can, right? Ultimately, to optimize our operation. All right, so besides the quantity, besides the total cost, by the way, if you counted the TAC, right, this Q star, then it is 176.2. $1,056.64. If we just plug the numbers in, I have all of the equation in the previous slides, okay, last week. So please trace back to the previous week slide, and you see all the steps. Then the cost right here is $176.64, right? If you project it to the left-hand side, then you see the value to be $176. All right, one more thing that I ask you here is, you know what, last time I might wrote it down during the class time. So that's why I have to fix it later on. Please check it, okay? The number in the class notes posted right now is the correct number. It is $176.64. Yeah, the last time I looked, because that 147 is the quantity, is not the cost. All right, so that's the total cost. Besides this, I also ask you to calculate the number of orders in the years, right? So the equation is, you would take the total demand for the whole year divided by the quantity that we order every time. So if you do it correct, then that number should be 4.39 orders per year, right? So the total demand is R, which is the weekly demand multiplied with 52 weeks divided by the Q star of 148. Then we have 4.39 orders per year on average. And then next we calculate the time between orders. How long do we have to wait, right? The time between orders is, you take the number of days in the year divided by the number of orders that we just calculated earlier, right above it. Right, then after we plug the numbers in, then the answer would be 82.92 days, right? So it means that on average, we wait for about 83 days before we make the next order. But remember, this number is the average number only, because in this fixed quantity system, right, we only fix this. We only fix the quantity that we order every time. And the time that we wait before the next order will depend on the demand. If a lot of people coming by, then we will need to make the next order very soon, right? Way earlier than 83 days. But if customers do not buy much, then we're gonna wait for more than 83 days before we make the next order, right? The 83 days here is just an average number. All right, so that's what we got last time, right? It is a brief review so that we can move on with part B. Actually, part B of this question, this example is very simple. By the way, I would like to remind everybody that this example is very similar to question 22 in our homework 4. All right, so in the next step, we need to calculate the IP, or inventory position. Or if it is a fancy word, then here is another way to call it, the current stock, right? How much do we have right now? The inventory position. So inventory position is calculated as how many calculators we have on hand, plus how many calculators are scheduled to arrive, to be scheduled to be delivered today, right? And then minus the back orders. How many calculators that we owe the customers? They prepaid for those models, right? For us to ship to them when we have them. All right, so that's easy. We just take the on hand, which is 35 on hand, 20 plus 20 to be delivered today, minus 2 back orders, right? Then we have the remaining stock to be 53 calculators. That's the IP. The remaining stock or the current inventory or the inventory position. Different ways to call it. All right. So in C, we would need to do the following. The question asks us to do the reorder point without safety stock. Reorder point without safety stock. All right, what does that mean? I would like to draw a picture to illustrate it. We call that as a picture of the service level. Oh, by the way, before that, I need to say something. So in this case, right, we need to commit ourselves to serve the average demand. Especially during the lead time. What is the lead time? We order something today and we still have to wait for the shipment. So during those days, we call it as a lead time, right? Because we have not received our merchandise yet. And you know what? When do we need to make an order? When our stock goes low, right? So the lead time is a vulnerable time because at the beginning of the lead time, we have very low stock, and then we still have to wait for the next shipment. So during the lead time, we might have a stock gap, which means that the customer come and then we have to say that we are sorry, we run out of stock. Actually, that is bad for us because we lose our potential revenue, right? So that's why in this case, we look at the lead time and we only commit ourselves to solve the average demand. And the picture for that is the following. So here's a picture of the service level. Okay, what I'm drawing here is the demand during the lead time, demand L or demand or DL, right? The demand during the lead time is a varying number because we talk about uncertain demand. Sometimes demand is here, sometimes demand is high, sometimes demand is low, right? But the demand will be fluctuating around the average. And that's why we assume that the demand follows the normal distribution of this. At the heart of it, we have the average. We call that as a mean or the average during the lead time. On average, we're going to sell that much. But sometimes demand goes beyond it, sometimes demand falls below it, right? So in this case, if we commit ourselves to serve average demand, then we will carry that much of inventory. We'll carry that much of calculators, right? And if we carry that much of calculators during the lead time, if the demand falls below here, then we will have enough stock to sell. But if demand goes up here, then we're gonna run out of stock, right? And so if we cut the distribution at that point, then we have 50% on the left-hand side, we have 50% on the right-hand side. Then we say that the service level here is 50%. The service level is actually this area on the left-hand side right here, where it is a probability the demand to fall below the quantity that we carry, right? We carry that much. So if demand follows below it, then we can service the demand. Otherwise, we have the stock out, right? So that's why on the left-hand side area, we call it as a service level. And the right-hand side area, we call that as a stock out probability. Right? So if we only carry up to the average demand, then we have the service level of 50%. So we call that quantity as the reorder point without safety stock. So RAD equals the average demand during the lead time, right? If we carry that much, we only commit ourselves to the average demand. And the letter R just say that it is a reorder point. All right, so the equation looks very simple, right? Because we can easily calculate the average demand during the lead time. To be more general, we're gonna find the average demand per day, and then we multiply with the number of days during the lead time. All right, so let's put some numbers in. The question gives us the demand per week. Then we will need to convert it to the per days, and then we would multiply with the number of days, right? So let me show you the calculation. So in this case, we need to find the reorder point without safety stock, meaning that we only try to solve to the average demand. So we would take the demand per day. The question gives us the demand per week, 12.5. So we convert it to the per day like this, right? And then we multiply with the number of days during the lead time. So they give us 3 weeks. And in each week we have 7 days. So we multiply 3 with 7. So we have the answer would be 37.5. But then we talk about the calculators, right? It cannot be a decimal number like that. So we would route it to be 38 calculators. Right. So that's the reorder point with without safety stock. So what to do with it? And here is how we would use that to it. So we call it as an ordering rule. The first thing is we need to monitor the remaining stock every day. We need to monitor the IP every day. How many calculators we have left, including the new shipment, right? And second, whenever the remaining stock falls below our reorder point without safety stock, right? When I say IP smaller than or equal to either equals or fall below the reorder point without safety stock, remember the reorder point without safety stock is 38 calculators, right? Then we would order Q stock of 148 calculators. Right. Okay, so the reorder point in this case serves as the threshold for the next order. Or we call it equivalently, we call it as a trigger point. Right. If our stock is high like this, of course, we don't need to buy anything. But over time, it goes low, goes low, lower, and lower. And then if it hits the threshold, right? Then on that day, we need to make another order. So the reorder point is a threshold or the trigger point for the next order. Right. So that's the ordering rule. And let's see if it is today. Then what would we do? So if we look at the today situation, the remaining stock is 50. The remaining stock is 53 calculators. And the reorder point is 38 calculators. I would like to ask the whole class, do we need to make an order today or not? Please feel free to share your thought in the chat window. Right, the remaining stock is 53. The threshold is 38. do we need to make any order today? All right, I see a lot of answers already. All right, so Nathan, Karina, VE, Jaylene, Jose, Fallon, Elida. Okay, well, good. You are quick, so I'm very glad. So in this case, right, because the remaining stock is still more than the reorder point, then we do not need to make any order because it means that we still have plenty of stock, right? Our stock is right here. That's the current stock right here. And it's still above the reorder point or the threshold, right? So we do not need to make any order today. We only need to make an order if it goes low, right? When we hit the threshold, it is a hint to say that we have low stock and then we have to make the next order, right? But today, because we still have plenty of stock, we do not need to make any order. We still have plenty of stock to sell. So there's no way, there's no worry about the stock out yet. Okay, so that's the ordering rule and the 2-day decision. And next, I would like to draw a picture to illustrate how the system works over time. And hopefully that picture will give you the intuition about the whole model that we work on right now. All right, so next I would like to show you the illustration of how the system works. I also ask you to do this in the homework, because if you know how to draw this picture, then you really understand the intuition behind it. All right, so here's the thing. We will need to draw it over time. So this is a timeline. And on the vertical axis, we're going to show the current stock, or how many calculators are left, right, in our store. Okay, so this is day 1 of the year. Go all the way to whatever days it is in the year, right? So we would draw the threshold right away, because we operate according to that threshold, right? So the threshold is right here. And we call that as a reorder point with dial safety stock. So the reorder point is right here. Of that 38. Okay, it is 38. Right. So assume that we on day 1 we are at the Q star level. Right. We have plenty of stock. Q star is 148. So we have plenty of stock. We don't have to worry about anything about stock out at all, right? And what happens is the following. Over time, the customer will come in back. And on that day, right, the stock is low enough. That triggers the next order. So we would order on that day. How much do we order? We actually order the Q star, the fixed quantity that we should order every time. And we order that Q star because that will help us to go to the lowest point on the cost curve, right? So that's the reason why we need to calculate the Q star right at the beginning. All right, we order on that day, but it doesn't mean that we receive the merchandise right away. Remember, we have the lead time, right? So here's a lead time. We have to wait before we can receive the merchandise. So during that time, the remaining stock continues to go lower and lower every day, because the customer still buys, right? And then on that, at the end of the lead time, we receive the delivery. So our inventory jumps up like that. Okay, by how much? By Q star. Because remember, we order Q star. So it jumps up like that. And then that's the end of the first cycle, right? And now the second cycle is the customer comes in by the way, when you draw the step here, the steps are not even, meaning that on some day we sell a lot, but on other days we sell little, right? So the steps are, sometimes it is steep, but sometimes it is shallow. Okay, so when the remaining stock hit the reorder point, right, then that's a hint for us that we need to make the next order. And of course, we do not receive it right away. We have to wait for the lead time. Right, that's the lead time right here. So during the lead time, the stock continues to go lower and lower every day. And at the end of the lead time, then one more time it jumps up by Q star, right? Because we order Q star, so it's gonna jump up by Q star. And then another day here, we need to make the next order. Remember, every time we order something, we order Q star. That's why we call it as a fixed quantity model. So on the shipment day, it's gonna jump up by Q star, right? Assuming that there's no back orders. If there's a back orders, you have to ship out something right away. So the quantity jump will not be in full, right? But if we don't have any back orders, then it's gonna jump up exactly by Q star. All right, so that's how the system works, right? Let me recap. We start at a very high point. The customer coming by, so it goes low, and when we hit the reorder point, we need to make the order on that day. And then it continues to go low, and then at the end of the lead time, we receive the shipment, right? Then it jumps up by Q star. So that's the end of one cycle. And then the next cycle right here. And then the next cycle, on and on, right? We might have multiple cycles in the year. So I hope you see how the system works, right? If we order the same quantity and then it's gonna jumps up and then it's drawn down like that. Here is another thing that I would like to ask everybody. Please think about it. So on that day, we make an order. We wait for another day to make another order. We call this time as a time between orders, right? So that's time between orders, number one. And then after that day, we wait for another day to make another order. So we call this as a time between orders, number two. And here's my question for everybody. What do you think about TB10, TB01, and TB02? Are they equal or not equal? What do you think? All right, somebody said equal, somebody said not equal. Theoretically, are they equal or not equal? Okay, so a lot more people say not equal. You are right, because in this case, right, we fix the quantity, but we do not fix the time. If customer buys a lot, then the drawn down here will happen very fast, right? It goes very steep like this. Then the time between orders will be smaller, right? In other words, if customer buys a lot, we have to wait very little before we make the next order so that we can replenish our stock to have enough merchandise to sell, right? So in that case, let me recap here, right? So in terms of the quantity that we order, we fixed it. Order quantity Q star is fixed. But then the time between orders varies depending on the demand. Possibly I happen to draw the two TBOs here very close, right? But in the reality, they do not have to be the same because the demand is fluctuating. In the high demand, the TBO will be shorter and shorter because we have to order it very early to meet up with the higher demand. But in the low demand time, right, then we wait for longer time before the customer buy and hit the reorder point. So the time between orders during the low demand time will be longer, right? So I hope you see that intuition, and that's the intuition of how the whole system works. But remember, in this case, we only try to retain. Yeah, we only try to retain enough inventory to solve the average demand during the lead time, right? Remember, the lead time is a vulnerable time. Our stock is continues to go low, and then we do not have the shipment yet, right? So that's why we might have the stock out during this time, and we only try to retain enough to solve to the average demand, right? So that's what we do in this part C. In part D, we want to do more. We want to retain more than this, so that during the lead time we have a higher chance to sell. We have more stock to sell, right? So that's let's move on to the next part. So in part B, we do the following. We need to calculate the reorder point with safety stock. So reorder point with safety stock. So in this case, right, we're gonna go beyond what we did earlier. Let me draw the service level for this situation. So again, we are looking at the same demand during the lead time, DL, demand during the lead time, the same demand structure or distribution, right? It's a normal distribution like this. The average is still here. But this time around, we carry more than before. We try to carry more than before. And this is more than before called the safety stock. Safety stock or ST, right? And we reach a higher point called the RST. We try to retain more for the lead time so that we have more chance to sell. So how much more chance to sell? Earlier, we only have 50% chance, right? But now the question asks us to do that so that we have 90% chance. So this is our new service level, right? So this is a desirable service level of 90%. We might choose it to be 95% or 85% or anything, but in this particular case, the question asks us to do 90%. So let's do that with 90%. And by the way, the stock out in this case will be 10%. Stock out probability of 10%, right? The remaining. By the way, I forgot to mention that earlier, right? The theoretical reorder point is right here, but after we calculate it to be 37 point something, we route it to be 38. So the actual point of operation is right here. It's a little bit more because we route it up, right? So I hope you see that, because we route it to be 38, not 37.5. All right, so now let's go back to the reorder point with safety stock. Now we try to carry more so that we have more chance to serve our customers, right? Which means that we have more chance to generate our revenues. And that's a good thing, even though we have to carry some more inventory. It costs more to hold on to the inventory, but might be the revenue, the extra revenue generated can well compensate for the increase in the inventory holding costs, right? Okay, so looking at this picture, then we have an idea of how to calculate the reorder point with safety stock. RST equals the average demand plus with the safety stock that we try to carry, right? Okay, so in terms of the equation, then we're gonna calculate the average demand per day times with the number of days during the lead time. If we stop here, it goes back to the previous method, right? But now we go beyond it. So what we do is we calculate the safety stock as norm. Oh, sorry. The Z value that depends on the service level. The service level is right here, 90% in this case. Multiply with the standard deviation of demand during the lead time. To be a little bit more concrete, what we will do is we do that as mu d times L. Right, everything here is per day and in days. That's our average demand right here. And then the Z value will be calculated as norm dot as dot inverse. That's our Excel equation. And we put in the service level, which is 90% or 0.9 in this case, right? And then multiply with the standard deviation per day, right? This one is for the lead time. But to be general, we're gonna calculate that per day. And then we scale it up to be the number of days during the lead time. Remember, this is a days. So let me show you how to do that with the numbers. All right, so it goes as the following. The reorder point with safety stock equals 12.5 divided by 7. That's the demand per day, right? Per week, and then we convert it to be per day. And then the lead time is 3 weeks times 7 days a week. So if we stop here, we calculate the average demand during the lead time, right? It's similar to what we did earlier, but we don't stop here. The next step is we calculate the safety stock. So first of all, the norm dot as dot inverse of 90%. If you try that in Excel, it's very easy. If you try that in Excel, then it's going to be 1.28155, right? Norm dot as dot inverse of 0.9. And we're going to get that. And then the standard deviation of weekly demand is 3.75, but we need that to be 1 day, so we divide that by the square root of 7. Somebody might ask me why the square root, because we need to convert it from the week to the day. Then we have to divide it by 7, right? But this is a standard deviation rather than the variance. If it is a variance, then you divide that by 7. But because it is a square root, sorry, the standard deviation is the square root of the variance. So that's why the square root shows up here, right? Just take it for granted. And over time, when we try the practice, then you might understand more. So, and then that's per day, and then we need to scale it up to be the whole lead time. The lead time is 21 days, so we would take the square root of 31 days like that. Okay, so if you do it step by step, then you're gonna have the following answer. Remember, this part right here is for the average demand during the lead time. This part right here is for the safety stock during the lead time. In the slide last week, I have all of the detailed steps. Here I try to talk about the intuition only, right? So the reorder point, again, is just the average demand plus with some extra stock that we try to have more so that we can sell more during the lead time. All right, so the answer is going to be the following. If you calculate it, it's going to be 45.82. But then we need to round it to be 46 calculators, right? Because that's the number of calculators. So the same as before, what do we do with this? First of all, we talk about the ordering rule, right? Number one is we need to monitor our stock every day, right? The on hand, the schedule receipt, and the back orders. We need to subtract the back orders, right? And when the remaining stock falls below the reorder point, this reorder point is different from before. Earlier it is 38. Now we try to retain more. So we start to buy something, to order something at 46 units, right? Not 38 units, because we try to have more during the lead time to sell. So if the remaining stock falls below that 46 calculators threshold, then we need to make the next order. And remember, this is a fixed order quantity. We would order the same amount, Q star of 148 calculators, right? That's why we call it as a fixed quantity system. We order the same amount every time. Okay, so if we follow this ordering rule, do we need to order anything today? So let's talk about today's decision. Remember, the IP is 53 calculators. The reorder point of the threshold is 46, right? So our stock is still more than the threshold. And for that, we do not need to make any order today. Right? Because we still have plenty of stock. 53 is still more than 46. And 46 is a threshold or the trigger point for the next order, right? But we have not hit that trigger point yet. So it means that we have to wait a little bit longer time or more time before we make the next order. Not today, right? Today we don't need to make any order. Any questions so far? By the way, in this part D, I also the question also asks you to draw the picture to illustrate how the system works, right? It's very similar to the picture that we drew earlier. Let me go back to the picture earlier. So earlier, we wait until the remaining stock to hit that reorder point, right? Then we have 38 calculators left to sell during the lead time. But the new reorder point is 46, right? Then we sell it a little bit and we hit the new reorder point earlier than earlier, right? Then we're gonna have about 46 calculators to sell during the lead time. So we're gonna have more chance to sell during the lead time, right? We have more stock to sell during the lead time. So I hope that when you go home, you retry this picture with the last part right here. You know how to do it, right? I hope now you get the intuition. So please practice with this multiple times because that might show up during the final exam. It's a high chance to show up during the exam. Any question for me? Right, so I hope that everybody is doing good. With that, we are done with module 10, right? The whole module 10 is about this model, about the fixed quantity system where we put our threshold, we monitor our remaining stock, right? And then we make the order when necessary. All right, so let's move on to module 11. Module 11 is the opposite of module 10. Another model to manage our inventory, but the rule is the other way around. In module 11, we're gonna fix the time between the orders, but then we let the quantity to order to vary over time. depending on the demand, right? So let me show you the example for module 11. And you know what? The example is actually question 25 of our homework 4. Let me show that to you. So this is homework 4, question 25, fixed period inventory system, right? So we have a corner store that sells milk jugs. The demand per week is 32. The lead time is 3 days, right? It takes 3 days for us to receive the new shipment of milk jugs. The ordering cost is $15 per order. The ordering cost, remember, is for the transaction fees, is for shipment, is for insurance, right? The cost associated with the order is not the cost of the milk. The $15 here is a cost for the order to be fulfilled, right? And then the unit cost here is $1.6 for a milk jug. And the annual inventory holding cost rate is 900% for a year. This number is quite big. Why? Because think about milk. Milk normally lasts only one month, but here if we keep the milk for 1 year, right? Just imagine it costs a lot of money to keep the spoiled milk jug on the shelf, right? So we assume it to be 90% for a week, for a year. 90% means 9 times the cost of a milk jug for a year to keep it on the shelf for the whole year. It got spoiled after 1 month, right? That's why the remaining 11 months is a pure cost to keep that spoiled milk on the shelf. The standard deviation of weekly demand is 7 jugs per week. We aim for the service level of 85%, right? And then 25 jugs current on hand, and we don't have any, today we don't have any schedule or delivery. So 0 jugs of scheduled receipts, and the back orders is 0, right? The customer walk in and buy, and if you run out of milk jugs, they just walk out and buy somewhere else. Nobody will prepay for the milks, right? So that's why the current back orders is 0. So it's very similar to what we did before. First of all, we find the EOQ, but remember, we would not order the EOQ in this model because we do not fix the quantity, right? We fix the time rather than the quantity. So the EOQ that we calculate in part A here is just the intermediate step for what we do next in part B. In part B, we need to find the fixed time between the reviews or the time between the orders. In part C, we find the current inventory position. Right? That's very similar to what we did earlier. In part D, we need to find the replenishment level with our safety stock. Right? We only commit ourselves to the average demand. And in part E, we try to carry more. So we calculate the replenishment level with safety stock, or MST, right? So it sounds a little bit similar to what we did earlier, but at the heart of it is totally different. Let me go through the sequence with you. Of course, we will not have enough time to cover everything today. So at the end, I will include the whole sequence in the class notes. Module 11 is about a fixed period system, or FPS. Right? We use this system for a particular merchandise. We might use the same. We might use a FPS for another merchandise, but it needs to be recalibrated using other parameters for other merchandise. All right. So let me remind everybody that there are 2 important decisions. One is about time. The other is a quantity. In this case, the time or the time between orders is going to be fixed. We fix the time. In the module 10, we allow the time to vary, right? And in this case, the quantity we allow it to vary depending on the demand. Okay, so that's the crucial difference between module 11 and module 10. Right, we totally switch or reverse the orders of time and quantity. All right, so to do this, we would learn about the FPS model. And to do that, our example is homework for question 25. In part A, you need to find the EOQ. By the way, it means that you need to redo this, right? Please handwrite so that you really understand it and upload the PDF file. All right, so first of all, we need to find the EOQ or the Q star. Remember, that's the square root of 2RK divided by C times I, right? So all the numbers are already given by the question, so we will do the following. All right, so we put in 2. The demand per week is 32, but then we have 52 weeks in the year. So remember, R is the demand for the whole year, right? And then multiply with K. K is $15 per order, right? And then the cost per unit is $1.6 per mil jugs. So we multiply 1.6 with the inventory holding cost rate, which is 90%. 90% means 9.0, right? So if you calculate this equation, then you're gonna have 58.88. But remember, we talk about the mil jugs, so we will not keep that decimal number. So the Q star in this case is taken to be 59 jugs. And we route it up. So please follow the question instruction, right? If I say route up, then please do it. Otherwise, things will be off from the answer keys. Okay, so so that's the economic quantity. Remember, we will not order this amount every time because we are under the fixed period system, not the FQS, right? We only do this so that we can do the part B. So remember, this is just an intermediate step. All right, so now let's go to part B. In part B, we need to find the time between reviews or T, or it is the same time between orders. Or TBL. Because in this model, we're gonna review and make the order on the same day, right? So the time between reviews or the time between orders are the same. To do that, then first of all, we need to do another intermediate step. We need to calculate the average number of orders per year. How to do that? Remember, the equation is just how many units that we need in a year divided by, on average, how many units that we would order every time. The Q star here, let's call that as an average number of order that we need to order, right? So let's put the numbers in. The demand per week is 32. And then we have 52 weeks in a year, right? And then if on average, if we order the Q star, which is 59 jugs, then this ratio will tell us the average of number of orders that we will need to make in a year. Right. For now, we because it is an intermediate step, then we just keep that as is. If I ask you for the average number of orders, then please calculate it to the end, right? But here, I don't think that in the question I ask you that, so just keep that as is. And then next, we will need to calculate the time between reviews, or T, or TBO. Okay, so we will do the following. We take the number of days in the year. We divide that by the number of orders in a year. Then we'll know how many days we wait before we make the next order, right? So let's put the numbers in. It means that the number of days here is 7 days a week, and then 52 days, 52 weeks, right? So that's the number of days in the year. Divide that by the 32 times 52 divided by 9, right? We just calculated that earlier. That is the number of orders in a year. So if we calculate this, then it's going to be 12.906, or in other words, we would route it to be 13 days, right? What does that mean? It means that we're going to wait for every 13 days before we make the next review and we make the next order. So that number means the following. We would review the remaining stock and make the next order every 13 days, right? That's the essential feature of this model. Earlier, we fix the quantity. No matter what, we order the same amount every time. And we let the time to vary, right? But in this case, we just fix the time. So today we review an order. After 13 days, we also review an order. And then another 13 days, right? We review an order. So that is why we call this as an FPS model. All right, so now we already have the time between reviews, and what we are doing next is the following. By the way, the next part is easy. In part C, we need to calculate the IP, right? So IP, again, is just how many meal jugs on hand plus how many meal jugs that will be delivered today, and then minus the back orders. So we have 25, nothing will be delivered today. And then we do not owe the customers anything, right? So our IP is 25 meal jugs, or jugs of milk. Right? That's how much we have today. That's easy, right? In part D, we need to do the following. We need to find the MAD. MAD is the shorthand for the maximum level or the replenishment level. Of inventory, okay? We talk about inventory here. So either you can either call that as a maximum level of inventory or the replenishment level of inventory. In the textbook, they even call that as up to, level, but I prefer to call this as a maximum level without safety stock. It means that we only carry to solve the average demand. That's why we're the AD right here, average demand, right? We commit ourselves to the average demand. So it means the following: we need to commit to solve average demand in, okay, in T plus L days. Why T plus L days? If we have plenty of stock today, we don't have to make any order. So we have to wait for T days, which is 13 days, right? Let me be a little bit more specific here. T is 13 days, L is 3 days. So we talk about the time horizon of 16 days here, right? So if we have plenty of stock today, we don't need to order anything. We wait for 13 days to make the next order, right? But then we do not receive the merchandise right away. We wait for 3 more days. In total, we have to wait for 16 days before we receive the next shipment. So during those 16 days, we might have stock out, right? So in this case, we only try to retain enough inventory to sell to solve to the average demand. So that's what we have in part D. So it means that we can draw the service level like the following. So one more time, we draw the demand distribution, right? This is the demand during T plus L days. So we assume it follows a standard normal distribution, right? It means that a lot of the time it will vary around the average right here, which is a mu T plus L. It's not L anymore, it's T plus L, because that's the time horizon ahead of us, T plus L, or 16 days. Okay, so because we commit to the average demand, right? So we only try to retain this much to sell during the T plus L days. But then if we carry only this much, then half of the time the demand will be here where we have enough stock to sell, and half of the time the demand will be here where we run out of stock, right? So we call the probability on the left-hand side as a service level, which is only 50%. And the right-hand side, that's a stock out probability, also 50%. Right? It sounds bad. And that's why later on we want to carry more in part E, right? Is that part E? We need to carry more so that we can go beyond this 50% service level, right? But that's for part E. Okay, so in terms of the equation, now we have a good idea of how to calculate the mu TL here. So mu T plus L, the average demand during 16 days equals the demand per day times with T plus L in days, right? They say that the demand per week is 32. So we would take 32 per week divided by 7 to have per day, right? That's our average demand per day. And then T plus L is again 13 days for the wait and 3 more days for the lead time, another wait for the shipment, right? So we have the answer here to be 73.14 days. I mean, jugs of milk, right? But then it can be a decimal number. So we would route it to be 74 jugs of milk, right? So that's the average demand. In this case, we go up a little bit. we go here, right? Not exactly 73.14, right? We go to the right-hand side a little bit. So our service level is more than 50% a little bit. The effective service level is more than 50%. Right. So we already covered the maximum level and what to do with it. So here is a rule to operate our inventory, to manage our inventory. So we call that as an ordering rule. So number one is we need to review our remaining stock, right? Every T equals 13 days, right? After every 13 days, we need to look at the system to see how many meal jugs that we still have, or we look on the shelf, check the back stock. In total, how many meal jugs that we still have on hand, right? So that's step number one. Step number two is we on the review day, we need to order a time-dependent quantity. It's not a fixed quantity. That's why we call that as a QT. The quantity depends on the time. Equals the maximum level minus the remaining stock, right? In this particular case, if we look at the numbers, we would order QT equals the maximum level is 74 minus the remaining stock on that particular day, right? So that's a general rule. So it means that we wait for the fixed interval of time of 13 days. And then on that day, right, we will need to make the order of 74 minus of whatever we have left over in our store. All right, so if today is a review day, then we order the following: QT equals 74 minus 25, then we have 49 jugs, right? So today, if it is a review day, then we need to order 49 jugs. I have very little time to show you the picture, but I will try, and then I will include it at the end of the class notes. Okay. So next we try to illustration of how the system works. Then we also draw the timeline, and then we show the IP on the vertical axis. And the maximum level should be at the top, right? So we draw the maximum level. That's our MAD. This MAD is 74. Okay. And then on the review day, we will try to replenish it up to reach up to the same level. Okay, so you know what? We can end our class here. I will complete this page, and then I will add more pages to have the complete sequence to go through the homework questions. Okay. On Wednesday, we will discuss it quickly, and then we move on to the next module and make the quick review. So please check out the review for the final exam online, so that if you have any question, please ask me. All right. So thank you all, and I would like to see you back on Wednesday. I will finish the slide that we have here.
All right. Thank you, Professor.
All right. Thank you. Yeah, thank you. So for those of you who stays back, first of all, we cut down the timeline to have the interval, right? This is a T right here. we wait for every 13 days before we make the next order. Even if we order it right away, but we still have to wait for the end of the lead time, right? So we draw the lead time right here. All right, so on the first day, assume that we still have plenty of stock, right? So it's gonna go down like this every day because the customer coming by. But then because on that day we review and make the order, right? So on that day, we're gonna order this much. We order the difference between what the maximum level is and what the remaining stock is. So at the end of the lead time, it's gonna jump up by this much because we order that much, right? And then that's the end of the first cycle, and then it goes to the second cycle like this. We hit another day where we need to make the next review and the next order. And then, so on that day, we need to make that order. That's Q2 right here to make up for the difference, right? So at the end of the lead time, it also jumps up by Q2. And then it goes like that. Another cycle that happens like that. Okay, so that's how you should draw the picture for this case. So remember, the time, the TBL, or the time between reviews is fixed. But the quantity, the order quantity, right, will be time dependent. Depending on the demand. Okay, so I will add more notes to the class notes and post it as soon as I can. So thank you. Any quick question for me? Are you good so far with the intuition or anything? Please feel free. Okay, so thank you all. I would oh, so Fallon, it means that it will be zero because there's a chance of stock up. The demand is uncertain, right? So it might hit zero earlier than that. Then it means that we need to theoretically we need to order on that day, right? But we might need to make the order on that day. Right, and then after that, we have to wait for another cycle of 13 days. Now, all of these are on the average basis. In the reality, it might looks a little bit different, right? Because of all of the uncertainty in the demand that happened. Okay, so I would like to thank you all. Let me close the current meeting. Okay, so yeah, see you back on Wednesday, okay? We will quickly go through this, and then we will move on to the next model. Everybody is welcome. Let me close the current meeting. By the way, I have my office hours today at 3, in case you have other questions. Then please feel free to come back here. Okay, so see you back on Wednesday.